Today we are going to be doing our review from our unit about the internet. So we learned throughout this unit that the internet is just this huge system of networks. We have networks connected to networks, and since it is not feasible for every single device to be directly connected to every other device, we're going to use a network of routers that are all connected together eventually. So let's say this is our network of routers, and let's just draw some connections. So all of our messages that we send across the internet are sent across all these shared wires from one device to the next until they reach their destination. Our messages are going to take the path of lowest cost, where cost is determined by how close the server or the router that we're being sent to, how close that is to our destination, how reliable that router is, has it been failing often, has it been going steady for a while, and what type of connection is being used. And we'll jump into that in just a minute. Now, this network of routers is both scalable, which means it can grow larger and continue to be effective, and it is fault tolerant because of the way that it's built. We are always able to add additional routers to the network. I can always add more, and that will increase the reliability of my network, and it will increase the total number of paths we have available. And if a single router goes down, let's say my message is taking this path. If I happen to lose this router, we're able to reroute that message to go, let's say we go here. And now we have still arrived at the same destination, but we've used a different path because there are numerous different paths that our information could take to get from one place to the other. So our system is fault tolerant because a single failure isn't going to bring the whole thing crashing down. Now, there are three different types of connection that we learned about that the internet makes use of. There are Ethernet connections, where we are sending information through electricity. There is fiber optic cabling, where we are sending information via light. And there are radio waves, where we send information via frequency, so using Wi-Fi or cell towers. And each of these three has their own benefits and detriments. When we send via Ethernet, Ethernet cabling is very, very cheap. It is much cheaper than the other two alternatives, but it does have middling range and a decent amount of latency added. Fiber optic cabling is very expensive, but it's also very, very fast and very long range with very low latency, because it's literally able to transfer information at the speed that light moves through glass, which is very, very fast. And our last option, using radio waves, this has the benefit of not requiring any wires. We do not need a physical connection to connect to the internet. However, it has the lowest speed and range of these three options, and also introduces the greatest amount of latency. So each of them has their own benefits and their own detriments. Every single device that we connect to the internet needs to be able to be identified uniquely so that it can be located across the entire network that is the internet. This is called that device's IP address. IP standing for Internet protocol. So our previous version of the IP addressing system, IPv4, is the old standard, and it uses 32 bits to store addresses. So we have 4 sets of numbers from 0 through 255. 0 through 255. 0 through 255. So we have 4 numbers, which is going to total up as 32 bits to store these addresses, which is going to mean we can store about 4 billion distinct addresses. Now, when they first created the internet, they thought, wow, 4 billion, there's no way we're ever going to hit that number. That is future-proof. We're perfectly fine. However, we have now got 4 billion distinct users on the internet. And I don't know about you, but I have at least 3 devices that I connect to the internet personally. So if everyone is like me and has at least 3 devices, there's no way that 4 billion addresses are going to work. So we have the new standard, IPv6, that are currently being shifted to, which uses 128 bits to store its addresses. It has 8 clusters of 4 hexadecimal digits. So we have so many more potential devices. We have 2 to the power of 128 distinct addresses. That is 340 undecillion different addresses that can be used for different devices. And we're pretty sure this is pretty well future-proofed. Don't think we're going to hit that number anytime soon. All right. So a lot of our lessons in this unit involved discovering the entire process by which we load a web page on our computer. So there are a lot of steps involved. And remember, they all are going to be happening in less than a second as long as our internet connection is good, which today on campus, it wasn't great, but that's beside the point. So there are numerous steps involved. Our first step is knowing what we are looking for and where it lives. So we are going to determine that using the URL, which stands for Uniform Resource Locator. Obviously, we are using it to locate resources on the internet. Every URL, let's say I have www. Actually, let's not do www.example.com. Let's say learn.vcs.net. That's our domain. And then if we /, what might we have as our path? There's all kinds of different things that could go into the path for a learn.vcs.net site. So let's just say view. View.php. That is what I am currently looking at on my screen. So we have our 2 sections. We have the domain, which is that learn.vcs.net, and we have our path, which is that view.php. The domain is going to tell us where on the internet we need to look for a resource, and the path is going to tell us what that resource is and where within that domain it can be found. So once we have determined what it is that we're looking for, we can create an HTTP request. HTTP stands for Hypertext Transfer Protocol, and these requests are the standardized language that computers are going to use to be sending and receiving internet resources. HTTP requests are going to contain all of the information about what exactly is being requested, which domain is hosting the resource, what resource is being requested, the format for the things we're requesting. So here we would be asking for a PHP file, what language the resource is in. All these different things are included in this request. So our computer is going to build this request, and then it's going to try and find the IP address for the domain that we are trying to send this request to. So our computer is going to check in its cache. That's its essentially its memory of IP addresses for any websites it has visited. So if the IP address for the domain we're visiting is not in our cache, we are going to use the DNS. So DNS stands for Domain Name System, and it is going to, this is a sequence of servers that are going to tell us increasingly specific information about the IP addresses for the website we're looking for. So we are going to start at the end. That is how DNS works. We start with the top level domain. So we are going to ask a root server, where can I find information about .NET websites? So my root server is going to have information about where I can find things for .com servers, or .com websites, .org websites, .NET websites, and every other top level domain, .tv, .co, whatever. So we're going to ask the root server, where's the net server? Where can I go to get this information? And we will get that IP address and move along. Then we will ask the net server, hey, where is VCS.net? And the net server is going to have information about any websites that use that .net top level domain. So we have VCS. I can't think of any other .net websites off the top of my head, but any other .net website is going to also be found on this server. So the .net server will tell us the IP address for this website, or for that server, and then we're going to go there and ask, hey, VCS.net, where is information about learn.vcs.net? Because it's possible that within that second level domain, there are subdomains, such as www or learn. We can access either of those websites within the VCS.net second level domain. So www and learn are both subdomains of that VCS.net domain. So that hosting server will tell us the IP address for learn.vcs.net, which is what we are eventually looking for. So we found the IP address of our recipient. So we now know where we are sending our message. All right, so we know where to send the message. So we are ready to send the HTTP request. Now, the whole message is not sent all at once. It is broken down into something called packets. So our whole request gets put into several little envelopes, each of which is going to have a specific information about the things that are being sent. So the formatting for these packets is determined by TCP/IP, these two different protocols. TCP stands for Transmission Control Protocol, and IP, like before, stands for Internet Protocol. So IP is going to contain information about the sender, the recipient, and how big the packet is, where TCP is going to include information about which number each packet has. So this is number 1 of 4, this is number 2 of 4, this is number 3 of 4, and this is number 4 of 4. So we label each of these with a to, a from, and all these other pieces of information. And all that data is called metadata. It's information about the information that we are transmitting. So we are going to then take all those packets and send them out across the network of routers, which we discussed earlier. They're all going to take their own paths. They do not all need to take the same path. They can each go their own distinct way through this huge network in order to reach their final destination, which was determined by that IP address that we found from the DNS. Then, when the server receives all of these packets, it's going to first check, did I get all of them? So if it somehow missed number 2 out of 4, 2 out of 4 is missing, it's going to say, hey, sender, please send that packet again so that I can actually recreate your request. So it's going to then have access to all of the pieces once that packet makes it successfully. Then it can reassemble all of those packets back into the original request because we have the order that they are supposed to be reassembled in. So even if they didn't arrive in order, that information from TCP is going to tell the recipient, this is the order you're supposed to put them back together. And the reason that this whole thing works is because both of the computers are following this protocol on how packets are meant to be created and received. So once we have that request, once the server has the request, it's going to read through it using a program because the request follows a very specific format, and it will determine what exactly is being requested. Once it knows what's being requested, the server is going to create an HTTP response to be sent back. This response is going to include things like a status code. Did we find what you're looking for? What is that thing locked? Did we not find what you were asking for? All these different things. And it will also include the resource being requested, assuming that it was found. And lots of other information that is very similar to the original request, such as the format of the data, the language, all these other things. So it's going to build that HTTP response and then break it down into packets, just like before. And since both computers know how to structure these packets, even if those computers were designed by different companies, even if they're running different operating systems, since they both are following these protocols, both of them know exactly how to disassemble or create these packets and then reassemble them when they receive them. So we create the response packets, we sent them all through the internet, and then our computer is going to receive those response packets. We're going to get those. We're going to reassemble them back into the original message, which is usually going to include some HTML information with the web page that we are trying to load. And then our internet browser is going to read through that HTML that it got and actually render it into a web page for you to view so that you can see the whole thing. And that whole process took less than a second to accomplish. All of this sending requests, receiving requests, all of these packets, all of this whole thing, less than a second. All right, any queries on how the process for sending a request works? That all clear? Cool. All right. For the other things we learned in this unit, we talked about sequential, parallel, and distributed computing. Each of these different styles is going to determine the method and order in which tasks are completed by a computing system. So if we are using a sequential system, tasks are going to be completed one at a time in the order that they were assigned. Obviously, this is the simplest, but also the slowest of these styles, because if we can only do one task at a time, we are clearly not going to be as fast as another one that can potentially do more than one at once. With parallel computing, we are going to be accomplishing multiple tasks simultaneously, using multiple processors that are sharing memory. So multiple processors within the same computer are going to share memory and be used to accomplish tasks. Usually, this is faster than sequential computing, obviously, because we can do more than one thing at once. This does, however, require a bit of additional setup and maintenance. It requires more work on our end because we need to ensure that everything is going to run smoothly, that there's not going to be any lockups, that everything will be able to go at the same time. It also opens up a bit more difficulty in troubleshooting because it's harder to find exactly where errors might be occurring. And our last type was distributed computing, in which our tasks are divided up between multiple different computers. It's very similar to parallel computing. However, our processors are on different machines rather than multiple within the same machine. Now, distributed computing is potentially more setup and more difficult to maintain than parallel computing, but it is very fault tolerant and it's much more scalable. We can increase the number of machines that we are using to do these calculations, to complete these tasks, without having to shut down the task completions. We don't have to add more parts to a single computer. We can just add more devices to the network and have more computing power. And similarly, it's very fault tolerant. If a single device goes down, we're still going to be able to complete tasks. We're still going to be able to run stuff, even if one of the machines in the distributed network happens to go down. With a parallel system or a sequential system, if the computer on which we are running tasks dies, we're out of luck. We are not going to be able to run any tasks because our computer is no longer functioning. So there are benefits to each of these different styles. There's simplicity. There is the ability to work multiple tasks at the same time with one device. And then there are fault tolerance and scalability within the third one. So there's that. We talked about cybersecurity. And since every piece of information being transmitted on the internet is traveling over these shared wires, everything is going over the same exact networks, it is possible for our messages to be intercepted by nefarious ne'er-do-wells. So there are many types of attacks that hackers can perform in an effort to gain access to either our information or the information of corporations, including distributed denial of service attacks, or DDoS. They can also do DNS spoofing. DDoS attacks are when a huge number of different computers all spam a web server with way too many requests for it to handle. So it essentially shuts down and is unable to perform any actions because it's getting way too many requests. And DNS spoofing is when a hacker inserts themselves into the sequence of DNS servers and feeds you an incorrect IP address and gets you to visit their website instead of the one that you were intending to go to. So in order to prevent these dastardly villains from doing anything heinous with our information, there are several different types of precautions that we can take. We perform encryption on all of the messages that we send. SSL/TLS encryption is used by computers around the world to ensure that messages cannot be read, even if they are intercepted. That's going to use the public key encryption method, where everyone has both a public key and a private key. Your public key is used for encryption. And your private key is used for decryption. If you're, when you are sending a message to someone else, you're going to use their public key to encrypt the message. Then when they receive it, they will use their own private key to decrypt the message. And since their device should be the only one with that private key, it's not possible for anyone to read that message while it's in transit. Another thing that we can use are certificate authorities, which help us ensure that the public keys we receive from websites are actually the valid ones. So we can check the public key that we got with a certificate authority to ensure, is this the correct one? Is this the one that belongs to that website in actuality? We can install security software on our devices, such as antivirus software, to ensure that our computers stay safe from malware, because they will do scans of your computer and delete any potentially fishy programs. And the last thing we can do is follow internet best practices. Often, we are the largest hole in our own internet security. So there are a variety of things that we can do to protect ourselves. We can have strong passwords on different websites. So if we have multiple different logins, we should have a strong password for each of them individually. We should not share our passwords across different logins. If we keep our software updated, that will allow the engineers in charge of that software to close security loopholes. And if we update swiftly, hackers will not have an opportunity to make use of those loopholes. And last, we want to make sure we're not clicking on any fishy links or downloading anything suspicious. Because phishing, jumping back up to here, phishing is a type of attack against you, the user, in an effort to get you to give the hacker important information, whether it's your name and date of birth, whether it's your credit card information, whether it's your social security number, any number of different things a hacker might try to get you to divulge when you really, really should not. So be careful, be wary of people on the internet, and yeah, be smart. All right, and our last couple of things. We talked about a large variety of different impacts that the internet has had on the world. So the internet, as we have said, is a philosophy of making information available to any and everyone in the world. This huge marvel of technology has enabled enormous impacts, both positive and negative. So I've listed 3 of the big ones here, although there are many more, as you'll recall from the lesson. The internet enables huge amounts of communication that has been unprecedented throughout history. People can send messages to one another in seconds from across the world. Information is now hugely available, and anyone can learn just about anything that they want to, without needing to do any hardcore research. There are scientific publications that you can find for free, or you can subscribe to for a nominal fee. Now, there is a dark side to this coin where not all information should be publicly available, like government secrets potentially. Not all government secrets shouldn't be known by people, but there are things like military plans, which could put people at risk if the general populace were to know about them. So there are certain types of information that should not be made public. E-commerce is a huge impact from the internet. It allows people to purchase things from their home. They don't need to get up and go anywhere. Now, it is still often very convenient to get up and go somewhere because you can pay with cash. You have instant access to whatever it is you are purchasing. But if you are purchasing from home, you can do research about what you're looking for. You can not be limited by your locale. If there's something that's being sold that is not available where you live, you are able to purchase it online and have it sent directly to your home, which is very, very convenient. And we talked about the digital divide, in which roughly 60% of the global population is currently connected to the internet, which is a huge portion. That's over 4 billion people currently connected to the internet. However, that's still 40% of the global population that is not connected to the internet. And so access to the internet and the knowledge it provides is going to vary greatly based on where you live and your socioeconomic status. Obviously, all of us are currently connected to the internet, so we live in a place and we are of the socioeconomic status where we have this access. However, not everyone is as privileged as us. So there are people all over the world working to solve this issue, working to bring the internet to more and more people, making it so that everyone has this equal access to this huge font of knowledge. So it's actively being worked on all the time, but it is far from fixed. And our last topic was creative credit and copyright. Whenever someone makes a work of art, no matter what kind of art they make, they become the owner for the copyright of that work. They can choose from a variety of different types of licenses, but they all fall into one of these three categories: all rights reserved, some rights reserved, or public domain. If a work is all rights reserved, the owner makes every single decision about how the work can be used, distributed, and modified. Often, large corporations, such as movie studios or music brands, are going to have all rights reserved types of copyrights, where if someone infringes on their copyright, if someone uses their media without asking for it, they will hound after them. Some rights reserved licenses, the owner allows for other people to use or distribute or modify their work, but they still require that they are credited as the original author of the work. So it doesn't get too out of hand so that other people don't claim that they made it instead. And last, if something is in the public domain, the owner has then relinquished control of how that work is to be distributed, used, and modified. The creator no longer has any control over how the media is used, because anyone is allowed to take it and use it however they choose. So when we are working on the internet, it's important that we respect the copyrights of other people, so that when in the future we might have our own copyrights, those are respected in turn. All right, folks, that is our review time